Now say in this example, there are two bulbs B1 and B2. So B1 and B2 are identical bulbs. Identical bulbs. It means they have got the same wattage. And now L and R are here. This is they are connected in parallel. This is not a pure inductor. This inductor L also has got resistance R equal to this, and this wire is also already has resistance R. So now here we have to just describe here, when this switch is closed, which bulb will glow earlier. So see here, as we switch the close this switch, what happens? Current start flowing. When the current starts flowing here, R is here, current going through this R, it suddenly reaches to its peak value, and bulb B2 starts glowing with the full brightness. But now the current going through this inductor, what happened? There is an inductive reactance, that is a resistance due to induction or induced EMF. So this induced EMF opposes the growth of current. So when the current is increasing from 0 to maximum value, inductive resistance or inductive reactance is opposing this growth of the current. So the brightness will not be full. So this bulb will not bright up here or will not light with the full brightness as soon as the switch is closed. It will take time, but after some time, as the current attains its maximum value, both the bulb will be glowing with the same brightness, because the resistance of this and this both are equal. So resistance of inductor is also equal to R. So both the bulb will be glowing with the same brightness after achieving the maximum value of the current. Similarly, when you close this switch, what happened? When you open this switch, as you open this switch, current is switched off. So this bulb suddenly stop glowing and its brightness reduces to 0, but here it will take time, because there is an inductive reactance. As the current decreases in the circuit, EMF is induced, which opposes the decrease of the current. Because of that, it will be gaining its brightness 0, but after some time.